Hello, hello, Shagath Unknown here. Welcome back to another Rust coding stream here on the 11th of January 2023, local time 17. And we see here a binary space partition interior. Very nice. Just kind of doing an example run or two of the algorithm here. See what we come across. Another BSP. That one's not going to be as exciting. Here's a good one though. So last time we added like better rooms and hallways. That's the nice little name I'm referring to it as. And this is interesting. I didn't expect a wave function collapse. But what we basically did was we added different room types. So we have like circular rooms and stuff that are that can be created now. The hallways were refined a little bit, and we also added new kinds of hallways like straight line hallways. And then we can even spawn things within the corridors, within the hallways. So I don't know what we're going to get. I mean, well, what we're going to get here, I think after wave function, it uses a Voronoi spawning system. So it's just going to kind of be whatever. But that was pretty cool to see. I haven't seen a wave function collapse on that yet. We got a good one here with the Drunkard's Walk. Collapsing that, and we should get decent results from that. So that's enough of reviewing what we've done in the past. Let's move on to the future now, and let's talk about doors. Now, we're going to see about doing two sections here, doors and decoupling the map size from the screen size. So that one I'm really excited about. Doors are a nice to have, and they'll make things a little more realistic. But I'm most excited about the decoupling. We'll see if we could do that today, but I don't want to run for like 4 hours like some of these early coding streams that felt like, you know, I was trying to cram too much into one session. So let's get started. Doors and corners. That's where they get you. If we're ever going to make Miller's From the Expanse, probably my favorite sci-fi novel series of the moment, warning come true, it would be a good idea to have doors in the game. Doors are a staple of dungeon bashing. We've waited this long to implement them so as to ensure that we have good places to put them. I mean, my initial guess is essentially that one of the things that we have track of now are rooms and corridors, so that could be, you know, related. We'll see. So doors are an entity too. We'll start with simple cosmetic doors that don't do anything at all. This will let us work on placing them appropriately, and then we can implement some door-related functionality. It's been a while since we added an entity type. Fortunately, we have everything we need for cosmetic doors in the existing components. Open up Spawner and refamiliarize yourself with it. Then we'll add a door spawner function. So we're going to copy this function, but just let's talk through it for a moment. We'll talk through it when I get it in the code because it's larger in my view here. It's a bit larger on the screen. So spawner.rs. And we have these other functions like shield and longsword and all these things, right? So we're going to add this one down here at the bottom. And it's basically the same thing as what we have on all the other ones. We're making an entity with a position. It's renderable. And in this case, we're saying it's a plus sign. And the foreground is chocolate. And the background is black. And the render order is 2. Don't forget about the render order. So that ensures that the player renders on top of something like an item, right? That's where a lot of that comes into play. With the name being door, and that's what's going to show up when we mouse over it, if we do that. And we mark it as something that needs to be serialized. Very simple. It's very much like our builder pattern that we did for the map refactoring, except in this case, this is more of what I consider a proper builder pattern where we actually chain the methods. .with, 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 and then at the very end we call a .build on it. And the .build returns us an entity. So that's what I kind of have in mind when I think of a builder pattern, is something where we actually do method chaining. Although it's not necessarily a big deal either way, it's the same concept. So we have that in place. So our cosmetic only door is pretty simple. As a glyph, plus as traditional in many roguelikes, it's brown, it has a name and position. It's really all we need to make them appear on the map. We'll also modify spawn entity to know what to do when given a door to spawn. So literally a string door, and it calls the door function. So let's go up here and just slap that in here. not much to it. The same as all these other ones, match the string with the appropriate function. We won't add doors to the spawn tables. It wouldn't make a lot of sense to have them randomly appear in rooms. So now let's talk about placing them. We're going to make a new builder, still in the map section after all, that can place doors. So in map builders, make a new file, doorplacement.rs, and let's go ahead and put in this boilerplate here. And it even describes this as an empty skeleton of a meta builder. We'll deal with the easiest case first when we have corridor data that provides something of a blueprint as to where doors might fit. So we'll start with a new function, door possible, and we'll get to that in a moment. I am going to make this door spawner, door placement in map builders. And we're going to slap that in there. We're going to go into our mod here and do mod door placement. Now we'll get our proper completion in here. And we have our skeleton as mentioned. And nothing is actually happening in the doors function yet, but that's by design, so we'll actually be implementing that in a bit. So the first thing we want to do is implement door possible. Okay, so we have a simple function here. It takes a mutable, or it takes a reference to self, not mutable, excuse me. Because this is returning true or false, whether it's possible. So we shouldn't be modifying things. Although we are taking a mutable reference to builder map. So interested in why that's mutable. I think I might have an idea as to why, and we'll address that when we get there. We take an index, so we'll see how that works as well. We might be checking the index of the map, that's my initial guess, and then figuring out what's around that tile. idx mod build data.map.width as usize, and let y equal idx divided by build data.map.width as usize. So we've seen this construct all the time now, so it shouldn't be new. We're going to check for east-west door first. So if build data.map.tiles index is floor, and now these are going to be beefy. We're checking x is greater than 1 for the boundaries of the map. We're going to see that on all of these. And we're going to check next to the tile. So we're saying build data.map.tiles index -1 is a floor. I want to just put the and over here. It should probably be at the beginning of the line though. Well, it depends. So x is less than build data.map.width -2. Okay, so there's a lot already going on here. We need to check for y as well. Although that does make me question something. And we'll address that in a moment. Oh, we're looking for walls. I did the wrong thing, that's why. Never mind. All right, just a moment. I got sneezes all of a sudden. Oh yeah, we have some slight issues. Tile type did not get pulled in correctly. It's not crate. And did I miss some casts? Let's see. This is very mad. We're going to put a false down here at the bottom. Okay, that helps us out quite a bit. Good. Okay. One moment. So x is less than build data.map.width minus 2. So x is usize, which actually that's being enforced up here. So this width is an I32. So we just need to cast those. Now let's take a look at what's going on here. We're going to the left of X and checking that it's a floor, and we're going to the right of X and checking that it's a floor. We're also checking against map boundaries to make sure we don't go out of bounds. So that's the first check. X is greater than 1 or less than map.width minus 2. And then down here, we're doing the same for Y, except we're checking the tiles above and below. So minus the width gets us above, and plus the width gets us below. And we're checking for it to be a wall, because in order to build a door, we need open spaces. I don't know how to draw it very well in ASCII, but we need open spaces for the door to go left and right, and then we need walls on each side of the door, right? So we're going to do the same thing for north-south. And I'm actually going to copy this because it's going to be the inverse of what we just did. So let's save a little bit of time here, and let's look at what's happening. This will also just return true. And now we are going to have this same thing getting a little mad here. I'm not sure why they got away with it in the tutorial. Unless at some point they changed what that map is, what the width and height are. But I thought the width and height were always I32s. And well, it is being cast as usize here. I just find that interesting. So now we check the same against the boundaries. I'm going to stop talking about the boundaries. And we check, is the left and right tile a wall, and is the top and bottom tile a floor? That's the only difference. So now we have a north-south door. So very simple. It's just very beefy conditionals. So if we go back over here, there really are only two places in which a door makes sense, with east-west open and north-south blocked, and vice versa. We don't want doors to appear in open areas, so this function checks for those conditions and returns true if a door is possible and false otherwise. Now we expand the doors function to scan corridors and put doors at their beginning. So we'll go to doors. And we're getting Hall's original. I'm okay with the if let in this case. So we're getting Hall's original with an if let. Did something wrong, didn't I? Oh, it's showing as unused. That should make it happy, right? All right. Um, yeah. So now we're gonna get Halls original.clone. Oh, we got a collapsible if. We'll take a look at that in a moment. Um, oh, because we nested it. Yeah. I see what it's saying. Actually, can we just have it do it for us? Yeah. If something, and then you do another if something, yeah, you could just collapse it. So that is kind of nicer. You could end up with very beefy conditionals like this, but it does remove some of the nesting, and it's the same functionality. So, what are we actually doing now? Very simple. We get the halls, we get all the corridors, and we're cloning it, and then we're looping over each corridor, each hall. For each hall, if it's longer than 2, and a door is possible at the starting index of the hall, hall 0, then we use that index, hall 0, to push into the spawn list a door. And that's all there is to it. Now, for this, we can actually remove that mutability on door possible, and it doesn't actually break anything, so that just preserves a bit of it preserves some safety there. Although I half expected it to be a little mad because we have mutable. I think it's fine to do that though, because it does get mad for other things. So yeah, I think we're fine. The tutorial text. Let's catch up on it. We start by checking that there is corridor information to use. If there is, we take a copy to make the borrow checker happy. Otherwise, we're borrowing twice into halls, and we iterate it. Each entry is a hallway, a vector of tiles that make up the hall. We're only interested in halls with more than 2 entries to avoid really short corridors with doors attached. So if it's long enough, we check to see if a door makes sense at index 0 of the hall. If it does, we add it to the spawn list. We'll quickly modify random builder again to create a case in which there are probably doors to spawn. So I'll go in and fix up random builder and we'll give it a try. And of course, this is not in yet. And let's see what we get. We're not actually taking snapshots or anything, so we won't see them yet, but here's a door. So as intended, that bottom room did not have one because it's not actually a long hallway or anything. This one does. That one did not for some reason. We have one here. It's very short though, I'm surprised. So I mean, it's an okay start. Did I do a sign wrong or something? Hang on. No, if hall.len is greater than 2. Just feels a little bit like we weren't getting as many as we should have. Well, we'll keep going. Actually, I'm gonna try one thing real quick. I'm gonna make sure I didn't miss a sign in here or something. We'll take one more look at it. There's a lot of really short hallways in here. Wow. We have one here. Okay. I feel like the diagonal ones don't work as well. I think that's what's happening. We do have one on the right there. So, I mean, it's okay. It is what it is. All right, let's go. So now we see an example of a door here. It's really hard to see. Still really hard to see. So what about other designs? It's certainly possible to scan other maps tile by tile, looking to see if there's a possibility of a door appearing. So we'll do that. So let's see. So we have this if let block here. And that's a way to say if there are corridors, do this stuff, right? We'll rip out the corridors and we'll work with them. If there are no corridors, we'll scan for possible places. So we'll clone our map tiles. Now we're going to have the same thing as before. This is going to be collapsible, so we'll go ahead and... Oh, no, wait, we're not doing that. Yeah, I'm sorry. We actually already had it collapsed here. I was looking at two different things on my screen. So we've already collapsed it here, my bad. I was going to say, so we're going to go ahead and do that. But this is basically the same thing, except we're checking every possible tile. So in this case, we already know about corridors, so we can save some effort. We already kind of know where we want to check. Here, we're just kind of blindly looking anywhere in the map that just happens to meet those requirements. And they're the same requirements. We're not changing the requirements or anything. So it should be interesting, to say the least. Yeah, we're not doing any snapshots, though. We don't want to even take one snapshot? I guess not. All right. But everything here is pretty straightforward, right? We loop through, we enumerate, that gets us our index. And then we do have this little safety check in, not safety, but sanity check in here. If the tile's a floor. That's being checked in here as well, but it prevents us from even trying if we already know that it's not valid. And as we're looping through the entire map, that just saves some time. So we're going to do a BSP interior, which we just saw at the start of the session today. A couple of those pop up. And this is very prime for doors. This is a very good map for a lot of doors. And we got a very good generation here for a lot of doors. A lot of small rooms. I like it. All right, begin new game. And let me scoot the browser over and readjust a couple things on my end real quick. Another thing we can look at is this door here. If I mouse over, it actually says door, which is expected. So the only reason there's no door here and here is because we're at the top of the map. Remember that we checked the map bounds, right? Yeah, we got doors all up in here. Now that looks a little funky, and maybe the tutorial will call it out because we're not checking if there's already a door nearby. So we may end up with cases like that, and I think the tutorial might call that out. We'll find out. In the case where it doesn't do these large cutouts, it looks great though. I mean, it will look better when we start doing our field of view, make it affected by doors, right? So it just says that worked rather well. So I guess we're just good for now. So we're going to restore the random function back to how it was with one change. We'll add a door spawner as the final step. So I'm just going to go do that. And you don't even need to watch because I'm just replacing the stuff that I already have in there. And I messed up my select. There we go. Oh, whoops. I put random builder inside random builder. I didn't realize I copied random builder, like pub fn random builder, so I pasted that inside of my function random builder. All right. Yeah, we're doing it before the vaults, and that's being commented on here. That's deliberate. The vault gets the chance to spawn and remove any doors that would interfere with it. There we go. So now we're going to make doors do something. They have a few properties. When closed, they block movement and visibility. They can be opened, optionally requiring unlocking, but we're not going there yet. At which point you can see through them just fine. So we're going to start by blocking out, suggesting some new components in spawner.rs. So we have blocks visibility, and this is something that we have not done yet, a new component type. So we're going to have some fun doing this. It's been a minute. So go back to spawner and we'll just replace the existing door that we have. And we have a couple of things going on here. A couple of new components that we haven't seen before. Everything else is basically the same, right? We didn't change position or renderable or name. Blocks tile. I don't believe that was there, was it? Yeah, blocks tile was not there before. So now we also added blocks tile, so we can't simply walk through it, but that's existing functionality that we already have, right? So we get that for free. Blocks visibility and door are new. And looks like door keeps track of its state, whether it's open or closed. So that's good. And we're gonna need to go to components.rs, which we haven't been to in weeks as we've been doing all these other things. And we'll come down here and put those two new components. Now remember, we're deriving component, debug, serialize, deserialize, and clone. And oh my goodness, that was loud. I thought I saw something pop up, but I didn't see what it was. Thank you for the follow, DNA snippet. Appreciate that. That was really loud. All right, so component, debug, serialize, deserialize, and clone are all in place, being derived for both of these new components. And blocks visibility doesn't really need any data, but again, the door is keeping track of its state here. So we're going to have to register these in main and the save load system. So let's go to main first, if I can even find it. Here we are. And let's scroll way down. And we need blocks visibility. And we need door. So those two are simple enough. Now remember, the save load system has the very beefy macros from before. Let's see, what are we looking at here? I guess we're just pulling in... Yeah, that helps. Getting the formatting was helpful there, actually. Okay. After single activation, I'm going to say blocks visibility, and then door. And then down here, I'm going to do the same. And, right, you can't do that in a macro. I forgot about that. No trailing commas in the macro. I don't think I need to register anything else in here. The big important thing to remember, it's been a long time since we've looked at these macros. The important thing to remember is that we serialize and deserialize in the same order. So as long as we preserve that order between one and the other, it shouldn't really matter which order you put them in, because you're just going to be getting the same components in the correct order. All right, so now we're going to extend the visibility system to handle entities blocking our view. So since the field of view is handled by our RLTK, that relies on a map trait, we're going to need to extend our map class to handle the concept and add a new, so we're going to add a new field. So let's go to the map.rs, which this has also been ages since we've been in here. We're going to have this here, pub view blocked hash set of usize, and this is basically defining what things are going to be blocked, right? Just which indices are blocked. So we're going to go into the constructor, and right after bloodstains, hash set new, just like that. Very simple. Now we're going to have this is opaque function down here that we implemented for map a long time ago, right? We're going to have to add another thing in here. So let idxu equal idx as usize. And this, for some reason, has been changed to an I32. Yeah, I don't believe that. Okay, I think what happened is the tutorial, the things got updated over time, so we don't need to worry about that. So we're going to say self.tiles index is wall, or self.viewBlocked.contains the index. And if we've set that index to be in view blocked, then that also tells us that it's opaque. So a very, very simple update actually allows us to, make something see-through or not in this case, but we're going to have a little bit more work to do. So we're going to need to go to the visibility system. And in the visibility system, for our data here, we're going to need to add another thing. We're going to add blocks visibility here. And then, of course, that means that we have to rip out that data here after names. We're going to say, how's it going, Jaeger? That's much better. I should have just made that on multiple lines earlier when it would have been more beneficial, but here we are now. So we're going to have blocks visibility. So we have the map, entities, the view shed, position, player, hidden, RNG, log, names, and blocks visibility. So right after that, we're going to loop through all entities that block visibility and set their index in the view blocked hash set. So like this. View blocked, dot clear, and then for block position and block Okay, so this is pretty simple. We've done stuff like this in the past, but it's been a little while. So we're going to join up position components and blocks visibility components. And for any that actually match up, we get this index from the position. We convert it to an index. And then we insert the index of that into our view blocked hash set tracker thing, right? Alrighty, so we're gonna cargo run that. I like chat right now. Hang on a second. I'll address that actually, and I'm curious about what you had to say as well. So that's really it. Yeah, we should have nothing else to check here. So the first response I would have is, what kind of stuff did you do with JavaScript and WebGL? And I've never touched WebGL. I'm interested in like the WebAssembly side of things, which I don't know if that touches WebGL or not, but you have like WGPU, which can work on your native platform. It can work in your browser and everything. And it might use, I think it uses OpenGL in the browser, so that may be WebGL, I'm not sure. But that abstracts away from most of the actual underlying API. So I'm not sure how that would work. So let's run this and let's check it out. But the actual question was, why does ASCII game look harder than everything I did with JavaScript and WebGL? I mean, it really depends on what you're doing and how in depth you're trying to go with the game. So this has gone pretty in depth so far with the number of different map generation algorithms and everything that we have. And also something got mad. Who's mad? I think I missed something somewhere. Oh, I never pulled these in. Oops. I think that might have been it. Yeah, that was it. I just forgot to include those there after we created them. All right, now we're going to make our BSP map here. And let's see if it correctly blocks our view. So one of the things I want to address with the talk about like why does this look harder than other things that you've done, one thing I actually would address here that I think is interesting is after we check this, yeah, we're not seeing through the door yet. And I can't walk through it. We're stuck. But that's good. That's what we've implemented right now. So yeah, this is the game now. This one room that we can't leave. So one of the things I would address is this started out very simple and it just grew more and more complex over time. So again, it depends on what kind of stuff you were doing with WebGL. This is using an entity component system, which is very, not necessarily complex, but it's a very flexible and robust system. It takes some time to get used to, but it's much more in line with something like data-oriented design. So entity component systems can be really good for making very performant games But you're kind of building things in a way that the computer's a little happier with than the human. So at first it may take some more time to get used to. So some of the things here, though, the way this is working here is actually pretty readable. This once you've got the entity component system set up, it's very nice because we say make an entity with position, with a renderable component, with a name, with the blocks tile component, with the blocks visibility, with a door component. Like all of that, it's almost like English. You're reading exactly what you're building. Here for rations, or for a shield, it has a position. It's renderable. It has a name. It's an item. It's equipable. It has a defense bonus. Or if we go to the weapon, it has a melee power bonus, right? So it's very, when you've got the system in place, it's very nice the way things come together. But the way you look at some of these systems and how they get built up, it does feel very complex at first. It does look it looks very intimidating. But once you start getting used to it, it's also kind of a nice system to use, because what we do is we get almost for free, we get to make these nice loops that just go over all the relevant entities. So here we say, I want all the entities that have a viewshed component and a position component. And then I have reference to all three of these components now. And I can do that for everything in the game that matches that simple description of those three components. So it's actually a very nice way to kind of filter down and do work on components and all that. And this can apply to any kind of game. This is a specific paradigm that can be used for any type of game. And a lot of what we're doing here, especially as we've gone from making the initial structure of the game in the past month and a half or so, has been map generation algorithms. Those algorithms are other things that can really be used for any type of game. So one map generation algorithm on its own is usually not that bad. It takes, a few minutes to understand the overall algorithm and the procedure that you're following to make the map. But as you start combining 15 different map generation algorithms, like we have around 15 or so, and you start layering them on top of each other, that's where the complexity starts to come in. But it's this complexity that got built up over time, right? So if you're kind of joining right now and you haven't seen the way it got built up for the past month and a half on these map generation algorithms, it makes sense that it's going to seem very complex. But because we've built up these systems over so much time, it's not as bad as it originally seems. We've got some nice traits and stuff in place at this point in our map builder system here, where we have the builder chain, which keeps track of the basic state of our map building. And then we have two traits that kind of do the bulk of the work here. We have an initial map builder, that's what we actually start out with. And then we have a meta map builder. So anything that implements meta map builder it's something that can be applied on top of something else. So we have all sorts of things that implement meta map builder, such as just adding corridors and adding rooms, or we can take one map and move it around and create a second map from the first map. So we can do a lot of crazy things like that. But again, this is built up over time. So that's part of why it seems, complex. I mean, at this point, if you were to sit down and just start looking through the thousands of lines of code, it would take a little while to break everything apart. But if you go through this from the beginning, it's not nearly as bad as it seems. So you're mentioning shaders, shadows based on depth buffer, if I can read. I haven't got into mesh generation, but that's something I'm interested in. I'm very interested in mesh generation. I'm interested in all kinds of procedural generation. That sounds fun, though. That's very different than anything that I've done, but it seems like some of the stuff you've done would be useful for gaming applications as well. I mean, especially the mesh generation. All right, so we ran this. We're trapped in the room. That's where we left off. We're trapped in the room because doors don't actually work yet. So now we're going to implement handling doors. So moving against a closed door should open it, and then you can pass freely through. So we could add an open and close command, and maybe will later, but for now we'll keep it simple. So we're going to go to the player.rs, which is another place we haven't been in a while. Basically, ever since we started doing map generation, we haven't touched any of the other real functionality of the game. It's all been a new map algorithm, another new map algorithm, or refactoring and making them better. So this is the first time we've been in here in a long time. And we want to go to the try move player function, which is here. And we're going to add a little bit more to this. So the first thing we want to do is we want to do this we'll do it down here. Let mute doors equal ECS.write write storage. Yeah. So we'll get the door. We need blocks visibility. And we're going to rename this to blocks visibility. Okay, come on, import that. Next, we need blocks movement. And lastly, we're going to need renderables, which we don't actually have. All right, so that's everything we need in here. This loop gets to stay the same, but we're going to need to do some extra work down here. So if position, okay, so there's our potential target here. If it's a target, that's cool. So we're going to do another if let down here. So this get mute gets us an optional mutable reference to a door because we don't actually know if there's going to be one here, right? Potential target is just our entity, which in an entity component system is really just like a number. It's an ID. So we're saying get us the door component with this ID, but if there's not one, it's an option type, so it'll be a none. So we're going to use if let to destructure that. And we'll just call it door. And now in this scope, we have access to the door if it existed. And we're going to set the door to be true, open now. Door open is true. So we're going to remove this entity from the things that are blocking visibility and movement now. We're going to do an unwrap on this one to get the renderable component, and we're going to modify it. If I can type. And we're just going to make it a slash for our open door. And view shed to dirty is going to rerun our view system, our visibility system. And that's going to make sure if view shed is dirty, well, that's going to happen in here actually. So this is going to happen regardless. My bad. This is going to happen regardless. So we're going to check view blocked, and that's going to clear out our hash set and everything. So that's good. View shed dirty is actually going to be what updates our field of view though. So that's going to be what lets us see through the now open doorway. And that's really all there was to this one. When we try to move, we see if there's a door there. If there is, we open it. We remove the components that are causing it to block visibility and movement. We set it to a new glyph, which is now an open door. And then we make our view shed dirty so we can recompute our field of view. And let's look at the text thing as well. That's my quick walkthrough. Here we see we obtain right access to the storages for door, blocks visibility, blocks tile, and renderable. We iterate potential targets in the movement tile, handling melee as before. We also check if potential targets are a door. If they are, we set the door open variable to true. We remove blocks visibility entry. You can see through it now, and so can monsters. We remove the blocks tile entry. You can move through it now, and so can everyone else. And we update the glyph to show an open doorway. We'll mark the view shed as dirty to now reveal what you can see through the door. And we'll do a cargo run on this and give it a test. It's not what I intended. Let's not have a labyrinth. This is better. This one will be a good test. Oh, we're wave function collapsing it. That's actually kind of not great. That'll make this one much harder to work with. But we may still get a door in a couple of places. Okay, I've been noticing something off on this. And yeah, I think we're having a slight issue there. We'll address it later, though. No, we don't want that one. Now, let's get this without the collapse. I might force it to generate something. There we go. All right, we can't see through it. If I do that, it now opens. And you notice our view updated. Watch it again. I'm going to move right now, and we see our view opens. We can see through the door. Very simple, but it is a nice, easy, quick implementation of the feature. So let's click back over now. So too many doors. On the non-corridor maps, there's a slight problem. When playtesting the door placement, there are doors everywhere. So we're going to reduce the frequency of the door placement by adding a little randomness. That one should be pretty easy to do. We're going to go back to our doors function in doorplacement.rs. And we're only doing this on the case where there are no corridors. So we'll come up here, we'll remove this underscore on RNG, and we'll say if tile is floor and door is possible, and RNG.roll dice. And what roll are we going to go with? A 1d3. A 1d3 if it equals 1. So there's about a third chance for it to actually produce a door. So 1 in 3 chance of any possible door placement yielding a door. From playing the game, it feels about right. May not work for you, so you can change it. You may even want to make it a parameter. So we're not really going to bother too much more with this right now. We'll give it a quick test run if we get a good map. Really depends on the map that we get. Cellular automata would be a good one. Yeah, that's corridors. I really don't feel like building out an entire thing here. Here we go. BSP interior, cellular automata builder. We'll do that. And instead of room-based spawner, we need area. No, Voronoi spawning. What are they again? That should be good, right? So we're going to do our starting position. We're going to call unreachable areas. Yeah, I think that'll work. Let's see what it looks like with a cellular automata. Because this could produce a lot of doors, maybe. Oh, there we go. Yeah. Wait, I was on one. Okay, no, I still feel like there's maybe too many doors. I don't feel like we're getting the right percentage here. And why don't I? Because it really feels like we're getting not 1/3. I'll put it that way. A 1d3. Let's try it again. Well, there's not a door here. Or up here. Or right here. So it is missing some doors. You know what? I think it's better than last time, though. And I think what might have happened is... last time, maybe last time I just hadn't hit save. Because I did go in and just hit save a moment ago. Maybe it didn't save the change. There's still a lot of doors, but... can I try... well, obviously I can, but... let's try like a 1d5. So give it about a 20% chance. Yeah, I'm definitely not seeing as many. But I'm also not seeing a lot of good, obvious candidates. Alright, I think we're good. Let's switch it back to the 1d3. And let's get back over to doors. So, doors on top of other entities. Sometimes a door spawns on top of another entity. It's rare, but it can happen. So we're going to prevent that from occurring. We can fix it with a quick scan of the spawn list in door possible. So that's easy enough. If speed becomes a concern, this would be easy to speed up. You can make a quick hash set of occupied tiles and query that instead of the whole list. We haven't really had any performance issues, and map building runs outside of the main loop, so it's once per level, not every frame, so chances are you don't need to. Which, yeah, of course. That's one of the things I've commented on a lot with this session, is that as we go through and deal with these map generation algorithms, I keep saying that performance may be impacted in some of these places, but to what degree it's impacted is the real question. Because essentially, okay, yeah, this is good. Essentially, to what when you're only running it once, as you generate the map, the user may not care, even if it's a second delay. They probably wouldn't care that much. It'd be like generating map. You could put a little message up even, and then they'd be like, oh, okay. And they would be comfortable with that. Or if it's so fast that it's imperceptible, performance doesn't matter. But if you're running it every frame, a hot loop basically hitting the same slow piece of code over and over will matter. So we're just going to say let mute blocked equal false. For spawn in build data dot spawn list dot iter. I'm going to redo this, but we're going to write it their way first. This to me feels messy. What's going on, Rose? I will get to that drink in a bit. I'm empty right now, so I will get that when I fill up. But I'm not sure when that's going to be yet, but I will get to that, I promise. All right, so as I said, this is messy. I don't like this, but it's simple, right? We loop through the spawn list. If there is something at the index that we're looking at, we set the blocked variable to true, and then we return false. If blocked is true. The reason I say this is messy is because we don't need a blocked variable. We can say build data.spawnList.iter.any, and then spawn. And then in here we say spawn.0 equals index. And we do that right there. And, oh, right. No, we do run into an issue. No, we don't. I was looking at something else. No, we're good. Okay, so if any spawn in our spawn list, spawn.0 is index, then we return false. Because what we're saying here, we loop through, and if a spawn.0 is index, blocked is true, and then if blocked is true, we return false. All of that here can be replaced with that. I think that's much cleaner. That's easier to read, easier to work with. And I think we're good. So, and there actually is a potential issue too that we're looking at now. And it's something I didn't expect to see here, but I called it out earlier. So that's the last major thing. And there's a slight addendum here called fixing wave function collapse. In our random builder, we've made a mistake. Wave function collapse changes the nature of maps and should adjust spawn, entry, and exit points. Here's the correct code. So that's something I was just calling out, that we're not cleaning up the map when we should be in that case. So we're going to go back up to random shape builder, or is it in here? It's in here. So let's do this. Let's uncomment this. And let's, this waveform collapse builder, we do this here. And now set the start, we do all that stuff. So basically, if it's wave function collapse, we run it. Then we do a starting position again, we do Voronoi spawning, we do distant exit. We're not calling the map, I don't believe, though. But that should fix most of the issues that I had with it earlier. And that is it for doors. There's definitely room for improvement in the future, but the feature's working. You can approach a door and it blocks both movement and line of sight, so the occupants of the room won't bother you. Open it and you can see through, and the occupants can see you back. Now it's open, you can travel through it. It's pretty close to the definition of a door. And that is it for the doors section. Now, I'm a little bit curious about this, but I think I do want to do this because I'm really excited about this. Very excited about this. I'm going to take a quick break between the sections here, just for a couple of moments, not very long, but I'm going to take a very quick break. And then when I get back, we'll look into decoupling map size from terminal size. So in just a few moments, we'll get to that. By the way, Rose, I hope those exams and stuff are going well. I know you said you had like 3 this week. The main one I remember is German. Oh, that's bleeding a lot more into the mic than I thought it was. My bad. I turned down the noise gate today. I didn't think it was gonna light up the mic like that. So, am Freitag, viel Glück an deiner Prüfung. Viel Glück mit deiner Prüfung. Alright, I got that hydrate right now. Just topped up on my water. Prüfung is exam. Viel Glück, with much luck. Viel Glück mit deiner Prüfung. Bitte. I took like 4 semesters of German. It's been a while though, I don't remember as much as I would like to. Back then when I was doing it, I used to play games in German. to help reinforce things in class, and that actually helped me a lot. So I was playing Fallout, for instance, and I would either put the language in German and the subtitles in English, or I would put the language in English and the subtitles in German, just to help me learn. Alright, I'm getting back into it now. Alright, so we are back in here now. We're going to look at the decoupling map size from terminal size. Very interested in this one, although it might be a little bit beefy. It's a little bit of a longer section than the doors, but I'm really excited to see this one through, because that's one of the most interesting things we can do, in my opinion, with map generation. It involves a lot of things where we're going to have to make a camera, for instance, and we can already see this here. We're going to have to make a camera, so that's going to be able to allow us to move around within this larger structure of a map. Again, to me, it's one of the most interesting things we can do. I've been waiting on this to happen for a very long time. I did something like this before. When I implemented Conway's Game of Life in SDL, I made it like I made this grid-based system, but I actually decoupled it from the screen size as well. So it's probably going to be similar to what we do here. I added the ability to zoom in and zoom out. I figured all this out myself, and it was a pain, because to do actual cameras and stuff, there are algorithms to do it. There's projection matrices and stuff that you can do, but I kind of figured all of it out myself and just made a system that worked, and it worked, but it was a pain figuring it out. So I'm wondering if we're going to do any zooming or anything here, or if we're just going to slide the view around. One thing to note here is that because it's a roguelike, it's a tile-based system, as we move around, the camera only has to move in increments equal to what the character moves in. So moving the camera is a little bit easier than a 3D or like a smooth scrolling system, right? So there are some advantages here. So let's get started. So far, we've firmly tied map size to terminal resolution. You have an 80 by 50 screen and use a few lines for the user interface. Everything we've made is 80 tiles wide and 43 tiles high. As you've seen in previous chapters, you can do a lot with 3,440 tiles, but sometimes you want more, and sometimes you want less. You may also want a big open world setting, but we're not going to go there yet. So this chapter is going to start by decoupling the camera from the map, and then enable map size and screen size to differ. The difficult topic of resizing the user interface will be left for future development. So, introducing a camera. A common abstraction in games is to separate what you are viewing, the map and entities, from how you are viewing it, the camera. The camera typically follows your brave adventurer around the map, showing you the world from their point of view. In 3D games, the camera can be pretty complicated. In top-down roguelikes, viewing the map from above, it typically centers the view on the player's at. Predictably enough, we'll start by making a new file, camera.rs. To enable it, add pubmod camera towards the top of main.rs with the other module access. And we're going to make a function render camera, do some calculations that we'll need. All right, let's get started with it. Notice how strongly I said the word at. I was like, that's a T, not an S. We're focusing on the player's at. All right. So camera.rs, and we'll go to main, and we'll go to our mods here. And we'll add camera. Now in here, we're going to need a couple basic starters as our includes. So we have the specs prelude, we have hidden map position renderable tile type. We also have RLTK's point, RLTK, and RGB. We're going to make a constant called show boundaries. And we're going to make that equal to true for now. But it's actually going to be, I'm guessing this is for, you know, show boundaries, like things that are like the map edge that we've been seeing tied to the screen. I guess we can just say we don't want to show that in some cases. We'll see how that gets applied. Because it's different now that we have a larger map. Maybe, yeah, maybe we just won't show the edge of the screen until we actually get to the edge of the map. Maybe that's what it means. So we'll see how that gets applied. Render camera. So we're going to need access to, we're going to take in the ECS, our world. We're going to take in our context, our RLTK. And we're going to need to fetch the map from our resources. And the player position, also from our resources. We're going to get the character size, which I think is going to be important because it's going to be based on... Well, that's going to be the size of our terminal, the active console size and characters. Okay. Interesting. So that just tells us how wide it is and how tall it is, our X and Y values there. And we're going to use those values to get a center. So we're just going to divide them by 2. Just like that. Now we're going to get min x, which is going to be player position dot x minus center x, max x, player position, oh no, min x plus x cares as I32. We're going to have to break down what's going on here. We'll repeat the same thing for y. Whoops, why did I do that again? Okay, so let's try to understand what's going on here. I'm going to give me a drink of water. Min x, player position minus center. Well, I wonder what happens. So if the player position is to the left of center, seems like you go negative. So let's say it's 9 wide. I'm trying to figure out how to draw this. That would be our center point. If the player is at, like right here, it actually goes negative, and they'll be like right here. No, because you're minusing center, actually, excuse me. Sorry, I'm trying to piece this together and like draw something out or try to figure out what's happening with this. So center X in this case would be 5. Well, it'd be like 4 because of integer division. So it'd be 4. So if our player position is 3, then min X is 3 minus 4. And then max X would be that -1 plus the total width of the console, which would be 9. So it'd be 8. So we go -1 to 8. I see what's happening. It's hard to explain, but I see what's happening. And I may not even be doing a good job explaining how I'm trying to think through this. Cameras are weird. So we've taken the player position away from the center. That gets us the left-hand side of our camera. Now we take that left-hand side and add to it the total width of the screen. So between min x and max x is the total width of the screen, but we've shifted it based on where the player is at. That's all that's happening here. And we do the same for x and y. So we do that for min x, max x, and we do that for min y, max y. So it's the same algorithm for both. It's a little bit strange. Let's get the tutorial breakdown on this because I'd like to see how they describe it. We create a constant show boundaries. If true, we'll render a marker for out-of-bounds tiles so we know where the edges of the map are. Most of the time this will be false. No need for the player to get that information, but it's very handy for debugging. We start by retrieving the map from the ECS world. We then retrieve the player's position from the ECS world. We ask RLTK for the current console dimensions in character space, so with an 8x8 font, 80 by 50. We calculate the center of the console. We set min x to the leftmost tile relative to the player, so the player's x position minus the center of the console. This will center the x-axis on the player. We set max x to be min x plus the console width, again ensuring that the player is centered. We do the same for min y and max y, and that's basically what I was just trying to break down and understand myself. And probably did a horrible job of explaining it, but it started to make sense to me of what we were doing. What I was saying is min x to max x spans the entire width of the console, but what I was leaving out when I was describing is the player is now in the center. And that's what we got here with this. Player position dot x minus center x. Okay. So we've established where the camera is in world space, that is, coordinates on the map itself. We've also established that with our camera view, that should be the center of the rendered area. Now we'll render the actual map. Okay, so let map width equals map.width minus 1. Let map height equal map.height minus 1. Let mute y equal 0. Now I'm sure we're doing the minus 1s here because we're going to be indexing with that. And, well, it's not just that we're indexing. We're doing something cheeky, I think. We will see, though. So we're going to set this let mute y, and then we're going to say for ty in min y to max y, let mute x equals 0. For tx in min x to max x. So yeah, we are doing that to check boundaries a little bit here. But it's a cheeky way of kind of doing it by restoring those values up there, map width and height. And then when we're checking TX against the map width and height, we're already accounting for the edge of the map. We're already accounting for the index and everything here. Yeah, exactly. So we're about to use this and it'll make more sense, I think. Because we're using TX and TY, we've already ensured that they're not going to be going outside of bounds. So we've kind of baked that logic in there. If map.revealed tiles IDX There's a lot going on there. And we don't even have that function yet, I don't think. So we're going to have to create that. We're gonna need a character in here. It's gonna be a dot, looks like, okay? Is that the same? Hang on, let me copy that. I don't think that's the same character. Yeah, it's a slightly different character than the period. Alrighty. A lot of stuff going on here, so let's take a look at it. We're looping through, again, the tiles. We go ahead and set this map width and height with the -1, so we're getting the offset there. On the out of, like, so we're not gonna have an out of bounds there or anything, right? Although we are still checking down here that it's less than, not less than or equal to. But I still think that's because we do leave 1 around the edge. It's not just... So the actual border of the map is also an invalid tile, if that makes sense. I don't know if I'm explaining it well, but what we've seen before when we've ran the game is that we have like an entire square around the edge of the map, and we're still kind of factoring that in. So the extreme border of the map is also not a valid tile. So this kind of builds that in, although it's a little bit obtuse in a way. So we basically loop through all the values that show up in our min y, max y, and our min x, max x that we calculated before. So this is everything that's within our camera's viewport, basically. And all we're saying, we get an index for it, and all we're saying is if it's revealed, we get the glyph for that tile, for that index, and then we set the context, which is just like drawing it to the screen, right? We're setting the context, which says the X and Y character that we currently have. And also, I missed something important. I was like, wait a minute, we're not incrementing them. I missed that. So after this context.set, we need to do that as well. Yeah, we're just going to be drawing them all over the same spot at 0, 0, and it's going to be dumb. So we simply draw that there in place. Now, if something is out of bounds, like this is not true, so we fall into this else if, but this only happens if show boundaries is true. And this is like our debug where we can see everything outside of the map as well. Then we go ahead and draw just a dot there for the outsides, which, you know, would be helpful to see as a debugger, right? So let's break down, let's then read the tutorial text here, because there's a lot to break down. It's kind of goofy, it's kind of weird right now. So let's read the tutorial text as well to get another view of what's happening. Similar to our old draw map code, but a little more complicated, so we'll walk through it. We set y to 0. We're using x and y to represent actual screen coordinates. Yeah, that's something I didn't make 100% clear, but when I didn't increment x and y, what that would have been doing is, because we're using them on ctx.set, that would have been the top left of the screen, 0, 0. We'd be drawing everything to 0, 0. But because we've already determined min x, max y, min y, max y, and min x, max x to be the width and height of the screen, we've already like set those camera values. Basically, this is the extents of our camera. Each tile that we loop through here represents one tile on the screen, but it may not be, you know, the same place every time, like what we've been doing before, where our maps are the same size as our screen. all of this would be identical. We have no need to have this code. But now that we can move our camera around, this is what's making sure that each tile we loop over between these min y's and min and max y's and x's, each tile that we loop over maps one-to-one to the tiles that are on the actual screen, in the actual console. So when we do ctx.set xy, and we increment these as we go through, that's how we're keeping those values in sync, because we already kind of defined it when we did the mins and maxes, if that makes sense. So we loop through ty, or we loop ty from min y to max y, and we're using tx and ty for map coordinates or tile space, hence the t. We set x to 0 because we're starting a new row on the screen. We loop from min x to max x in the variable tx, so we're covering the visible tile space in tx. And we'll do a clipping check. We check that tx and ty are actually inside the map boundaries. It's quite likely that the player will visit the edge of the map, and you don't want to crash because they can see tiles that aren't in the map area. So we'll now calculate the index of the tx ty position, telling us where on the map the screen is located. This screen location is, excuse me. If it is revealed, we call the mysterious getTileGlyph function for this index, more on that in a moment, and set the results on the screen. If the tile is off the map and show boundaries is true, we draw a dot. Regardless of clipping, we add 1 to x. We're moving to the next column. We add 1 to y, since we're now moving down the screen, and we've rendered a map. So it's actually quite simple. We're rendering what's effectively a window looking into part of the map rather than the whole map. And we're centering that window on the player. Yeah, so that window is, again, defined all by these min x, min y, and max y. That is our window. And that moves around based on the player position. But again, it is the size, because of how we calculate it, it is always the correct width and height of our screen. Because we did x chars and y chars based on the size of the actual console. So there's a lot of interesting things kind of going on there at the same time. So now we need to render our entities. So let's do that. So we're just going to do that in here, it seems. After that loop, we'll do... I'm going to be a little lazy on this one because I don't feel like typing all these storages. And we've done this before. We actually did this a few minutes ago, grabbing most of the same stuff. So we're going to get our positions, renderables, hidden components, and our map resource. And we're going to say let mute data equal positions, renderables, not hidden. And we're going to join that up. And we're going to collect it into a vector. So we're actually just holding this vector for the moment. And we're going to sort it. We're going to sort it by render order. And we've done this before a long time ago, but that's because we have render orders. This is useful for when the player stands on top of an item or something. We want the player to show up, not the item. So we defined a render order, which is a priority of what goes on top. So we're going to render it from lower render order to higher render order. That's because we have B compared to A. So because we went second and then first, we're actually going to go from the lower priority render to the higher priority render. So what we'll do is we'll draw an item on the screen, and then later we'll say, oh, here's the player, and it has a higher priority. So we'll draw that over the item. So we'll no longer see the item. But that's very, very critical to make sure things actually show up as intended. Now that we've sorted it, we're going to loop through what we have. So just loop over data.iter and pull out position and render. We don't care about hidden. And let index equal map.xy index. Position X and position Y. If map.visible tiles index. So this is saying if it is visible, then let entity screen X equal position.x minus min.x. And we'll do the same for Y. There we go. I made a typo on min X, but that's fixed. Now we got a big old beefy boy here. Entity X, if entity screen X is greater than 0, and it's less than map width, and entity screen Y is greater than 0, and guess what the next one's going to be? And it's less than map height, then we're going to set the context. So ctx.set entity screen X, entity screen Y, that's where it's positioned, render.foreground, render.background, render.glyph. And that is it. So the text here says, if this looks familiar, it's because it's the same as the render code that used to live in main.rs. There are two major differences. We subtract min x and y from the x and y coordinates to line the entities up with our camera view. We also perform clipping on the coordinates. We won't try and render anything that isn't on the screen. We previously referred to get tile glyph, so here it is. So we'll go ahead and draw that in a moment. I'm gonna give me a drink of water. And and let's go ahead and do tile glyph. So I guess that's going to be here in camera. I think so. Well, actually, yeah, we're not referencing it from anywhere, so it should be here in the local file. So it's going to take an index called usize, or of type usize, and it's going to take a map. And it's going to return RLTK font char type RGB RGB. Now we want to do a little bit of work here, so we're going to say glyph foreground and background is what we're returning. None of that exists yet, so we're going to make glyph and foreground and background. We're going to initialize background to RGB from F32, 0.0, 0.0, and 0.0. So we started out as black, and then we're going to change it as necessary. And I think I need to... Oh, that's actually a period, okay. Oh, because floor, yeah. I was like, I think I need to copy that. That's the dot. But no. So if it's a floor, we're matching on the map tile. If it's a floor, then we set that to the glyph, the period. Foreground is equal to RGB from F32, and it's going to be 0.0, 0.5, 0.5, if I can type. Next, if it's a wall, so tile type wall, what's it going to be? Let x equal idx as i32 mod map.width. Let y equals idx as i32 divided by map.width. Again, that's a construct we've seen many times before, but remember, if you're doing mod and divide, it's width both times. And in the case that it's a wall, we don't have this wall glyph function yet either, but we're gonna get this X and Y. We're gonna do wall glyph. I know why we're doing this. The question I would ask for the viewer is, do you know why we're doing this? Well, my guess, my very logical guess, based on the previous lessons, even though it's been a very long time, we did bit sets for walls that determined, based on how many walls are like adjacent to each other and how they're arranged, we have a different glyph for each type of wall. We're probably moving that into the function here called wall glyph to decide which wall to actually use. So that'll be how we set the glyph there. And we'll do downstairs. And if it's a downstairs, then we want the glyph to be 2CP437. And we do that right there. Boom. From F32 on our colors 0.0, 1.0, 1.0. And that's all of that. Now if map.bloodstains, why do we not, hold on, let me make sure. Oh, it's not happy because of wall glyph not existing yet. I think. We'll keep going for now. If bloodstains contains this tile, we need to do background equals RGB from F32 0.75, 0.0 and 0.0. So we're just going to set the background to be a blood red color. And if not, map.visible tiles dot, so if it's not visible, then foreground equals fg.to grayscale, background equal RGB from F32 0.0, 0.0, 0.0. There we go. Lots of work there, but I think most of it's pretty straightforward. We match on what tile type we have, and we set the appropriate glyph. If it's a floor, we set it as a dot. We set the color, right? That's not really anything special. If it's downstairs, we set the greater than sign, set the right color. Wall glyph, we got to make an extra decision. We'll look at that in a moment. If it's a bloodstain, we change the color of the background to red. If the map is visible, we make sure the background color stays black. And we set the foreground color to grayscale. And then we return everything that we created. So the tutorial text says this is very similar to our code from the draw map function we wrote ages ago, but instead of drawing to the map, it returns a glyph, foreground and background colors. It still handles bloodstains, graying out areas that you can't see, and calls wall glyph for nice walls. We've simply copied wall glyph over from map.rs. Is that the actual function from before? We have is revealed in wall as well. And that is a copy job. We've written it before. I'm not going to do it again. So this is back in the bit sets, like better walls with bit sets section from a couple months ago. We could take a look at that again if we want. But the basic idea here is there are 16 possible combinations of how walls can be arranged. We have a pillar because we can't see neighbors. So if there's a wall only to the north, if there's a wall only to the south, a wall to the north and the south, a wall only to the west or the north and west, each different combination of walls basically gives us 16 different combinations, right? 0 to 15. And we can store that in a variable and use the different possible values of like numbers here. We're basically building out, again, a bit set, but we're kind of doing it in a simple way using the match here. We're not actually getting down to the level of specifically looking at different bits or whatever. But we do have to kind of know what some of these values come from and what they represent with the value we're returning here from the match. We do have to know what those are because they're coming from the CP 437 character set. But I mean, as for this here, this is really simple because we just build it up from these is revealed in wall, right? So we add 8 if this is the case, we add 4 if this is the case, we add 2 if this is the case, we add 1 if this is the case, and that's actually what gets us all of our different combinations. So we are using a U8, which can actually support up to 256 values, but we're kind of treating it like it's only a 4-bit number, and we're just kind of building up the 16 possible values with the different combinations here. It's probably a terrible explanation. But what you often see if you're dealing with a bit set is actual bit shifting and stuff, and we're kind of getting away from that. We don't really have to do that because of the way we're using the match statement. So in some ways it's nicer, in some ways you might prefer bit shifting, but I guess it's up to the user. It's been a long time since we did this, but again, you kind of have to know what some of these values represent based on the character set. I mean, I can't really speak to exactly, you know, oh, this is that exact tile, but we could go look at the character set and see what each one of these represents again. And we see them in the game all the time, but the example in here is this like plus thing. If there's a wall on all sides, we get this plus thing. And that only happens in this one case, 15. And so let's actually just real quick, spending more time than I need to, how do we get to 15? If is revealed and wall for x plus 1 and y, so we're going to the right of our tile, we add 8. If we go to the left of our tile, we add 4, so that gets us up to 12. And then here, if the tile below is also a wall, then we add 2, so that gets us up to 14. And if the tile above is a wall, then that gets us up to 15. So 4 simple checks here built up that value of 15, which says there's a wall on all sides. Very interesting way of doing it. I like it. It's been a while since we looked at that. And then is revealed in wall literally just checks the values from the map and just says literally what it says on the tin. Like, it's not special. All right, so we're going to be able to remove that out of map at some point. I'm not going to do that yet. We're going to keep running with what we have for the moment. So finally, in main.rs, we're going to go make things better. So we need our run state. Let's see. What is going on, Tusk? GUI, there's draw UI. This is where I want to be at. We can replace all of this with something much, 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 much shorter. Look at this, all this right here. Boom. So camera, render camera, self.ecs, context, and we do the same thing with the GUI draw UI, and that's it. Everything else we needed to do that is already, or to like what we used to be doing in there is now in the camera, but it's also already decoupled from the map. So we've already gained new functionality that we're not really going to experience yet, but we'll experience a little bit of it, but we're not going to experience the bulk of the functionality until a little bit. And yes, Hotline Miami 2 is really good, Tusk. Actually, I think I played the second. I know I played the first and loved it. All right, let's get a map here. I still remember when we first implemented this algorithm and it was my favorite. I was like, that's cool. Begin new game. And there we are. So we actually have a camera moving around with us now, which already feels pretty cool. I like it. Kind of a vast improvement already, in my opinion. It's a little bit harder to navigate in some ways because as a player or as the developer, I got to see the whole map be generated and I kind of got a sneak peek at where everything was at, and this disorients me a little bit. As a player without that knowledge of the map being generated, it's perfectly fine. And thanks for dropping in, Rose. I appreciate it. I got you on the hydrate there. Auf Wiedersehen. Or a tschüss. Tschüss is better. Less formal. Alrighty. So we got our camera working. Our basic camera working. We're going to be adding some extra stuff here. We're going to be fixing a bug first, apparently, because we didn't move tooltips or targeting. If you play for a bit, you'll probably notice that tooltips aren't working. They're still bound to the map coordinates, so we should fix that. First of all, it's becoming obvious that the screen boundaries are something we'll need in more than just the drawing code, so we'll break it into a separate function in camera.rs. And I think I'm going to copy that because it's code we've already written. We just wrote it. We're just refactoring it out. So we'll go in here and before render camera, we'll do get screen bounds, and we could see that the code is the same, right? Player position, X chars, Y chars, all the way up to min X, max X, min Y, and max Y. So we can actually get rid of all of that now. We still want to get the map, so now we'll go here and we'll say let min X, max X, min Y, max Y equal get screen bounds, ECS and context. Very simple. All right, nice refactor. We didn't really have to change much of anything. And that, you know, buys us a lot of usefulness in the future as we're going to be doing that. So the tutorial text says it's the same code from render camera, just moved it to a function. We've also extended render camera to use the function rather than repeating ourselves. So now we're going to go to GUI.rs, which has been a while. And in GUI, we're going to edit draw tooltips to use the camera position quite easily. So draw tooltips. First thing, we're going to get all that same stuff, min X, max X, min Y, max Y. Although some of these are going to be unused, it looks like. Camera get screen bounds, ECS CTX. And we're going to have to bring camera in here. Okay, next. I probably could have made camera a pub mod in main and avoided some of this. So some of my imports are really messy in here. I would actually want to spend some time cleaning them up, but because we're going through the tutorial and things are so frequently changing and I can't predict how they're going to change, I don't want to spend that time doing it until later. So we get the min X and all that good stuff. And we get our map, we get names, positions hidden, mouse position, okay. Where is it used? Okay, let me just kind of read through these carefully. If mouse position 0, oh no, I see what we're doing. Okay. Let mouse position is that, and now we say let mute mouse map position equals mouse position. why do we even do that? Can we not just make this mutable and change it? How odd. Mouse map position dot zero plus equal min x mouse map position dot 1 plus equal min y. And now instead of mouse position dot 0, it's mouse map position map dot width minus 1 mouse map position dot 1 map dot height minus 1 or another or if the mouse map position is less than 1 or dot 0 is less than 1 or mouse map position dot 1 is less than 1. So we're actually checking for map boundaries there, which is something we've done many, many, many times. And we do, before the tooltip, we want to do another thing here. If not map dot visible tiles XY index mouse map position dot 0 not to own, don't do that to me. We'll return in that case as well if it's not visible. And then we'll do the tooltip stuff. For name, position, hidden, all that's fine. We're going to get the index. Actually, we're maybe not. Let's see. We're not doing that index there. We're going to say if position.x equals mouse map position dot 0 and position.y is mouse map position dot 1. And we've already checked the visibility here, so we can remove that now. And we'll push the tooltip in. And there we go. So our changes are, at the beginning we retrieve the screen boundaries with camera get screen bounds. We aren't going to use the max variable, so we put an underscore before them to let Rust know that we are intentionally ignoring them. After getting the mouse position, we make a new mouse map position. It's equal to mouse position, but we add the min x and min y values, offsetting it to match the visible coordinates. We extended our clipping to check all directions so tooltips don't crash the game when you look at an area outside of the actual map because the viewport's at an extreme end of the map. Our comparison for position now compares with mouse map position rather than mouse position. That's it. The rest can be unchanged. If you cargo run now, tooltips will work. Well, let's find out. What if I don't believe it? What if I think they are lying? Let's find out. Oh, we got the slowest algorithm. All right, while it's going, I'm gonna just blow my nose real quick. See that? It's still going. We really should speed this up by making it take snapshots every 5 or 10 or something. We've done that before on another algorithm. Drunkard's Walk or something like that. This is diffusion limited aggregation, I believe. And that's my only complaint with it, is the implementation is very slow because we take too many snapshots. I think we may even be taking snapshots when we're not modifying anything, because there is a delay between tiles often. Maybe not. We should be getting close to... I'm going to wait this out. We're here. We're doing it. Of course, you wave function collapse it. Actually, we already knew that that happened, though, because... What in the world? Got a weird incoming call. I'm going to ignore that. If they leave a message, they do. It's a name I don't recognize. Oh, what a terrible map. Tooltip is not working on the stairs. It's working on the rations, though. So we're okay. One of the problems is wave function collapse still has some issues, and it's usually not that bad, but these are things that I called out a long time ago, and they've been kind of persistent with the algorithm. It is on the tutorial. I would personally be addressing them more, but we're trying to make progress through the tutorial at the same time. The implementation works most of the time, but occasionally we get that terrible result like we just got, where it was a tiny square room with nothing in it. Oops. I would want to design slightly better heuristics for the way that we're building out our map there. But, you know, that's a stretch goal for something we could do at another time. All right, so let's get back to the next section now. I mean, tooltips are working, so now we have to fix targeting, which is going to be about the same. If you play for a bit, you'll notice if you try to use a fireball or a similar effect, the targeting system is completely out of whack. It's still referencing the screen map positions from when they were directly linked. So you see the available tiles, but they're in completely the wrong place. So we should fix that too. And I think I'd like to grab a scroll and test it before we do this. So let's get an easy map here. This one's... we're collapsing it. This is okay so far. So we are way over here in the corner. I can't tell if it actually left multiple stairs or if that's just the way the pattern looked. I still think there's some issues with some of the wave function code, unfortunately. We should really address that. We did another collapse here, and it's giving me terrible results today. It's not normally that bad. I might spend some time between streams, and then I'll like document what I did. So magic missile, I think that just automatically targets, doesn't it? We got a shield. Come on, give me another scroll. I don't want to sit here and play for ages, but I want to test it. Is that, that's confusion, which I think works. Yeah, we can see the problem here. What's actually happening is, if we take a look at it here, This bit here, this little curvy bit at the top, is actually my field of view going out of this doorway, right? So if I move to the right... Oh, I need to... How do I cancel? There we go. So see, now that thing is at the top, right? That blue bit's at the top here. So again, what's happening is it's a mismatch between the screen coordinates and the map coordinates. So that's what we're trying to fix now. So we're going to go into the code for a ranged target in GUI.rs. We're going to make sure we just adjust how we're doing that. It's probably going to be very similar to what we just did for the tooltips. The first thing we're going to need is this same long destructure, so I'm going to be lazy and just copy that in. This is what we've done a few times now already. I just didn't feel like typing the whole tuple out. We're going to get our min x and max x and all that fun stuff. We're going to print color, and then I got to make sure that I don't miss anything here. So there's a lot of things that may or may not change. For index, let distance. So yeah, so this is one we're going to be changing in the if distance is less than range. Let screen x equal idx.x minus min x. Let screen y equal idx dot y minus min y. And now I have a new check in here. Now we're going to move this stuff in here. So we're basically just checking the screen X and screen Y against our actual like camera values, our max X and max Y. The basic stuff that we've done before. Slightly different arrangement here, but it's the same general idea, right? We want to make sure that they're in valid positions. And then if that's the case, we'll set the background and all that should be happy. Now for the mouse cursor, mouse position, and then we're going to do let mute mouse map position equal mouse position. And there we have it. So we're going to do the same thing we just did on the other one by adding min x and min y to our mouse map position. We're going to have to do a couple checks for this in a few places. So if index.x equals mouse map position.0, and this one's also going to be mouse map position.1, then valid target is true. If it's a valid target, context.set background, we get to leave this as mouse position.0 and 1. But where we set this point here is going to be mouse map position like so. And those are the only other things that change. So this is fundamentally what we had before with a few changes. One, we obtain the boundaries at the beginning, once again with the camera get screen bounds. In our visible target tiles section, we're calculating screen X and Y by taking the map index and adding our min X and min Y values. We then check to see if it's on the screen before drawing the targeting highlight at those locations. We then use the same mouse map position calculation after calculating mouse position. We reference mouse map position when checking if a target's under the mouse or selected. So if we run now, targeting should work. So let's give it a try. Let me scoot a couple things around real quick. You won't see it, but for my own sake. And hopefully we get a good, easy map to work with. This is a good one. Even if it does a wave function collapse on it, this one usually has a lot of open space, easy to work with. You expand that. I think it's my first time running in one of these with the camera system as well, so it's pretty cool. Don't kill me, because that's exactly what I want right there. The fireball is good. So if we do this, we hit fireball. Nope. See, we still have a slight problem. I was afraid of that. I thought I saw an issue. That's fine, but what we're drawing is not fine. And I thought I saw an issue, but I am following the tutorial, and I think they made a slight mistake. They set the background, so let's actually look over, and this is what caught my attention and why I skipped over it. They set the background based on mouse position, not mouse map position. So I think that's a slight issue, and I think that's what we need to be changing. It stood out to me, but I decided to give it a go, and then we'll figure out what's happening. But I think it does need to all be mouse map position, because that's our position modified by our camera coordinates. And the tutorial is allowed to have typos. It does happen. It's happened before. So let's give this another test. Hopefully we get a good map to work with. You know, I might even just cancel it if we don't get... Yeah, this is not a fun one to use for this. Too many doors and what? Dude, I said no. Too many doors and walls and stuff to go through. Oh my goodness, it's giving me all the binary space partitioning interiors, and I want a big open map. There we go. Of course we collapsed it. It shouldn't be too bad, but yeah, I think there are some errors here since we did a few modifications. That's another thing I mentioned before that I want to address. It seems like wave function collapse has a few extra issues. Let's go to another floor, see what we get. Here we go. This is exactly what I need. So do this, hit fireball. Now we're almost there. We have a little bit of an offset from that highlighted light blue spot, don't we? Yeah, we're still having a couple offset issues here. So let's kind of keep drilling through this a little bit, okay? Oops. Sorry if you heard that. Let's keep drilling through this a little bit and make sure we do this correctly. So I want to go back up and just start looking through from the start. We get our min X and max X and all that fun stuff. And we print color, that's fine. Select target, all that's good. Nothing special about it. Highlight available target cells. So this is the first thing I want to take a look at. Visible is all based on the view shed, so that part's fine. We have a view shed. For index and visible, okay, we're going to loop through all those. We're getting player position, that's fine. If distance is less equal range as a float, as F32, then screen X is idx.x minus min X, and screen Y is idx.y minus min Y. If screen X is greater than 1 and screen X is less than max X minus min X minus 1, I might have missed that on Y. I did miss that on Y. So that's a bounce check that was slightly off that would have probably resulted in a crash later. Screen Y is greater than 1, and screen Y is less than max Y minus min Y minus 1. And this is another one that I slightly missed. And that's a big deal. So there we go. Now everything gets set to blue. Available cells, and we return, and that part is fine. Okay. I'm going to give this another quick go, because that may have been the only issue, was that I was setting the wrong index there on set BG. Well, the cyan was slightly off too, though. Dude, I'm not doing that algorithm right now. It's too slow. It produced good results, but yeah, this is what I want. This is a good one. Come on, I need a scroll. I need a good scroll, come on. What are you? Magic mapping. It's helpful. Are we at the bottom of the map there? Am I gonna have to change the spawn rate? Come on. It's annoying. It's really annoying when you can't find what you need. Ah, nerd goblin stepped on the trap. I stepped on a trap. Really, all this without a scroll, huh? Try another floor here. I'll modify the spawn tables if I need to. Magic missile's okay, right? Yeah. We're getting this offset though for the cyan. The red and the cyan are getting the offset. And I think that's actually why. So those should have stayed. The original error that we had, I think, fixed it. And those were unnecessary changes. So the backgrounds from the mouse position are still fine for that, but the other ones that were based on the screen for the actual like targeting areas, what we needed to change it for. Let's take a look, and I'll try to make that more clear. Give me a good one. Too slow. Waiting 5 minutes for that thing to generate. Oh, Voronoi Hive map. That'll be a really good one. Even if it does wave function collapse, there'll be a lot of open space to run around. That's a really good one. A really good map there. I like it. All right, let's find a scroll. Is this, oh, those are these stairs? Oh, right. We had the issue with wave function collapses generating extra stairs. It's not clearing out the old stairs, so when it uses the pattern with the stairs in it, they get duplicated. That's an easy fix. We could actually do... We could do that in wave function collapse, which I kind of thought we were, but we might have changed that when we were implementing meta map builder and stuff. All right, shield, I'll equip it just so I don't die. Any scrolls or anything good? We'll equip the dagger as well. Got rations. No scrolls, apparently. Gonna make things difficult for me, isn't it? Come on, we want to see this thing working. All right, let's eat something. All right, let's just take one of these stairs and try our luck on another map. Just checking those unexplored areas real quick. Magic missile, there we go. And yeah, we did fix it. Awesome. Okay. So we can see our FOV is going around the wall as we kind of expect. If I walk closer to the wall, click somewhere invalid. And walk closer to the wall. See, it's kind of moving more around now. Good stuff. You can just see straight down this way, a little bit out. Yep. Cool. And we could shoot right there if we want. Although I did actually, yeah, it doesn't go unless there's a target. But cool, we did fix it. There were no typos in the tutorial, but the typo I made was I was still setting these to be the incorrect. I was using index, which was still based on like the map and everything. Is based on the visible tiles. And it should have been screen X and screen Y as we convert it based on the camera. So slight issue on my part. Again, it's a little bit difficult when you have, let's go back to the text here. When you have a function this size and you're looking for about 10 lines that have been modified, if that, maybe less than 10 lines, it can be a little difficult to catch something as simple as CTX, like right here. You know, I go line by line and I do my best to catch it, but that happens sometimes. So fundamentally, it's what we had before with some changes. We obtained the I think I already read this, but we obtained the boundaries at the beginning with get screen bounds. In our visible target tiles section, we're calculating screen X and Y by taking the map index and adding our min X and Y values. We then check to see if it's on the screen before drawing the targeting highlight at those locations. We use the same mouse map position calculation after calculating mouse position. We then reference the mouse map position when checking if a target's under the mouse or selected. And we just saw it working, so I'm not going to run it again, but there's a little image that's hard to see because it's tiny. Variable map sizes. Now that our map isn't directly linked to our screen, we can have maps of any size we want. A word of caution, if you go with a huge map, it'll take your player a really long time to explore it all, and it becomes more and more challenging to ensure that all of the map is interesting enough to want to visit it. So an easy start is, with the simplest possible case, we could change the size of the map globally. So we'll go to map.rs, find the constants, and just change it to a square map. So let's give it a try. I think I have map.rs open. I do. Scroll to the top here, and we have this 80 by 40. We're going to do, by 43, we're going to do 64 by 64. And if we cargo run, it should work. We've been pretty good about using either map.width or height or the constants throughout the program. so the algorithms run and try to make a map for your use. So the player will be able to wonder a 64 by 64 map. And the sides of the map are going to be a little bit different now. So let's take a look at it. Simplest change we've done in a while. But what we really want to do is we want to be able to parameterize it and do some things with that, I can imagine. Now, the way we view the generation here does not quite work very well. Our test harness doesn't look as good as it used to. So I'd like to see if and how we address that. Because we don't have a zoom in or zoom out feature on our camera yet, if ever we will. And because of that, if we design things that don't really make sense, yeah, that was a... Wave function collapse is busted. I'm going to have to look at that. I might take a look at it even before we wrap up, but we're running pretty long today. It is busted. It's generating terrible things half the time. You know what? Just a quick look at it. If we wave function collapse, when we go in here, do we not get rid of the stairs, first of all? It doesn't look like it. We just do this self.build, and build takes a snapshot, it generates patterns, but we're not getting rid of any stairs. So why are stairs being placed before this? Well, I tell you why. Distant exit is down here, but we already call it. It's already being called here in our random shape builder. It calls unreachable. It does all of this stuff in here, and then we're duplicating some of that functionality in here. I think we do need to take a little bit of time to look at that. It's not going to be the most difficult thing to do, but I'm wondering why it got set up the way it did. Because for these functions, at a point, I stopped writing them and I copied them from the tutorial because it's just the same boilerplate over and over. You know, a bunch of random dice rolls in a match, adding things with, you know, builder.with and so on. And I said, well, that's fine. We've written this 10 times before. I'm not going to keep typing it. We'll just copy it in. Make sure I don't make a typo or something. And now we have this weird situation where wave function collapse is basically broken. So in the case that we do a random shape builder, the builder chain, okay, let's look at random builder. Yeah, it either does random room or random shape, but in both cases, again, we already put the stairs on there. One option would be a very simple meta map builder to say, if we're going to do wave function collapse, remove the stairs. That's actually one of the simplest things we could do, is just to say builder.with remove exits new, and we won't have duplicated exits. But that's only one problem we're dealing with. We could also simply do that in here. Before we do anything else, before we build patterns, we could iterate through the tiles, build data.map.iter. Is it not .map? Hold on. .map.iter, .tiles, .iter mute. And we could say, actually, no, I don't even want to do that. Dot filter. And we want to say tile. We'll do, put an ampersand there. And then we'll say star tile equals tile type floor. Not floor. Downstairs. And then we actually want to modify that. Can we do a... We can do a map with that, right? Just want to do a for each. I don't think we can modify it that way with the map, can we? Because we can... I don't think I've ever tried mutability in a map. We can do that just to set them back to floors. Oh yeah. And why are you immutable? What am I doing wrong here? It's a mutable reference, so if we dereference that, can I move out of a shared reference? What am I doing wrong in this one? Yeah, we could just do that. The double. I don't like doing the double deref on those, but it doesn't matter, but I just don't think it looks as good. Once we put the reference here, I think that's what caused the issue. So we could do that to remove the downstairs. We won't get duplicate stairs. The next one is our constraints. I never really liked the way our constraints were set up. I would also call it like a heuristic. We're using that heuristic to decide whether something is valid or not. And I think we're allowing too many cases of placing tiles. I think it actually that would be the compatibility matrix part. If there are no exits, is that the one? If there are no exits at all, it's compatible. We allow ourselves to just place tiles that don't actually match. And I feel like that's one of the issues. Because we end up just randomly doing all this crap that then gives us a tiny map because we call everything, and then it's like, oh, well, now all we can do is walk around a tiny square. We can't do anything else in the map. So I almost feel like commenting that out. We'll just open a lazy scope there. This is going to make it a lot more difficult to even generate a working map. We may have a lot more failures, but I'm genuinely curious to see what kind of results we get here. And I'll have to try it a couple times. And this gets back to another thing I wanted to talk about as well, but no, we didn't do it that time. Let's try it again. I'll have to try it a couple times until we get one to happen, just because I'm being a little lazy. Now, there are some other things that we would definitely want to address and make sure. I think our algorithm's actually working pretty well right now, though. Yeah, the way those halls generated there. Okay. So it says, oh no, it's not possible. If you look in the bottom corner there. So it actually failed once. Now, what's actually happening is it fails really quickly in the back end, and you don't get to see that happen. But it failed to find enough matches, and it gave up. So now we're seeing the second run of it, and we don't really clear the map. So you still see the old one, and then you're kind of pasting the new ones on top of it. So it's a little weird looking. But what did it generate? What are we going to actually explore? Because it said that was okay. I mean, we actually have a bit of a map going this time. I can't really complain too much. Runs us out to the edge. Where are the stairs, though? Let's try to explore this one real quick. I want to see the results. And I may actually leave our wave function collapse as I've just modified it. We should only have one set of stairs now. If at all. Did I break something? Or did I miss them? See, I may have broken something. Yeah, I think there's still some work to be done here. That map was already a little more promising than some of the things we've dealt with, though. Yeah, because I've not really been happy with the way the constraints work. That's been something that I talked about a long time ago when we first implemented it. And this one's going to be fine, yeah. Oh, that's, magic missile. I thought that was stairs. That was, of course it's not stairs. Magic missile. Hit that man with it. All right. I think we will bring this back to its previous state here. And I'll just keep in mind, I really do think we should modify the constraints a bit one day. Because I'm not 100% happy with the way it's set up now. Distant exit is there. And Voronoi spawning. So it should have made an exit. We'll see. If this gets collapsed, it'll be a good candidate. I hope it does. I guess I should just remove the conditional. I should just say do this no matter what. I don't really feel like doing that one right now. Yeah, this is better. Just for a quick test, this one will be better. Now, something, we're going to be done with the tests here after this. We're going to continue on with the tutorial. This little wave function collapse side step or whatever we're going to call it here, because I don't want to keep going down this rabbit hole. There's a lot I could do. What we're seeing right now is the next problem that I hope we address. We'll see if the tutorial wants to address it or not, but it's basically that we spawned right by stairs again. We're at the edge of the map. Yeah, we're still having that issue with the constraints, but we have stairs now, so... What? Did I just... I can't move down. What's happening? Oh, something's broken. What in the world is happening? How did I break it that bad? So, I noticed it as... As I moved around, it's like I warped a little bit. And then things got weird. We're going to remove this. I'm going to probably take some time between sessions to look more into this and just get something I'm a little happier with. All right, so let's continue on here and finish up this session. Oh, but actually the thing I wanted to mention is, I kind of already did, but with the 64 by 64 map, we don't get to see the generation properly anymore. I think it'd be nice to implement a zooming feature so we could see the whole thing. We zoom out or something, but right now it's kind of borked looking, and hopefully we'll do something to fix that. So the harder way of changing the map size is going to be removing the constants. So we're going to delete them, watch the IDE paint the world red. Before we start fixing things, we'll add a bit more red. So now the new map will take a width and height. And creating a map requires that you specify a size as well as depth. So we could make a start on fixing some errors by changing the constructor once more to use the specified size and creating the various vectors. All right, so let's go back to the map. And delete all three, yeah. Delete all three. And in here we have the depth. We're also going to take width and height. And now, before we do this, we're going to use map count a lot. So let map tile count is width times height as U size. And everywhere that we see map count, we replace it. And we replace width and height, except we can do it the lazier way. Like that, because they're the correct types already. Map.rs also has an error in draw map. Looks like it's way at the bottom here with map width. So fortunately, it's an easy fix. So map dot width if x is greater than map.width times map.height as I32 minus 1. What do we... Why did... That's one question I have. Why does the original code have width and the modified code from the tutorial has width times height? I don't believe it. I really don't believe it right now. We're going to put a pin in that and maybe come back if I have an issue. But what we're doing is x plus equal 1. If x is... width.height is the very last tile of the whole thing. Like, that's not really... I don't think that's correct. We're going by each... we're going through each row, right? We keep incrementing x until x gets to the width. Minus 1. And then we reset x to 0 and we move y to the next row. We move... Yeah, I think that's a typo in the text because it says it's the same code, but it just says width times height. I don't buy that. We'll remember to come look back here if there's a problem though. So next up is spawner.rs. Map width is no longer here. And then spawn entity is like the only thing here. So we're going to need to get the map though. And then we'll get the map width as U size, and then the two places that we're using it. I mean, I really feel like we could have just said map.width on both of these. I don't know. You have to do as you size both times, but whatever. And then after this, we're going to do a mem drop on it. Just to stop from borrowing it. And save load system, which we have open already. So super map count. Yeah, and delete me. We already have the world map. Now this is actually going to be correct. We're going to get the height times width here. Because that's what map count used to represent. Main has a few things going on here. Magic map reveal. Let's see. Map width. We already have the map. So we could just do that. If row as you size equal, we can actually get rid of the U size. Yep, because it was already an I32. Map.height is an I32. So we're good there. And none of the other stuff is affected. There's some stuff going on way down here. Because we're making the map now, there's a slight issue. I don't see that being addressed yet. Oh no, there it is. Okay, 64 by 64. Size doesn't really matter since we'll be replacing it with a map from a builder anyway. Yeah, that's our starter. It actually doesn't matter, yeah. That's just to get a resource in place that we can use. Now player.rs. It's not really complaining, but we've committed a real programming sin. We've hard-coded 79 and 49 as map boundaries. Oh, we have. If map blocked. Yeah, actually, that's something I probably called out when we did it a long time ago. Because I would have been like, I don't like this. We made constants for a reason. I don't know why we did that in the first place. But hey, whatever. It's good. Map builders. Let's take a look in there. We have a couple things going on. We're going to introduce a couple more errors before we fix what we have. So in mod, we'll store the requested map size. So builder map. Where are we going to put it? Right down here. Pub width, I32. So we have width and height. We're almost done with this section, by the way. So it is going to be a pretty beefy one today. We're going up on 3 hours, but I think we'll be able to finish at about the 3-hour point. So it'll be okay. It'll give me a little bit of time to relax tonight as well. But we're right at the tail end here. Once we get this working, I don't think we'll be changing much more today. So we have that. Now we need to do this builder chain stuff. And we're going to say width, height. And if you're paying attention, we don't have one of those. So we'll pass those in. And the map also needs them. We're storing it for the builder chain so that all our constructors that care for it can use it, I would imagine. We'll see. There's only one other thing that's mad, though. We'll need to adjust the signature for random builder. Just a width and a height. There we are. We'll visit waveform collapse mod. which I just spent some time in. Basically, all our references to map new also need to include the new size. So like that. We already have build data, so we'll use it. Okay. Then we'll go back to main. What are we doing in main? Oh yeah, because we still have... We just changed something that now makes this mad. So in here... Pass those values in now. And that's it. If we cargo run, we can roam a 64 by 64 map. Let's give it a try. We've already kind of been doing it. Here we are. Really need to implement God mode. Need to... I might do that for fun. I'll probably make a new component. And if it's active, then it ignores damage or something. So then in the damage system, it'll just check to see, like, does it have God mode? Does it have invincibility or whatever? And then I'll just make that toggleable with, like, the G key or something. So this is cool. We have a decent map now. Let's quit that. And it says if you change that line to a different size, you can roam a huge map. So generate world map, we could do 128 by 128. So twice as large as the last one. We don't see anything happening, but it is happening. It's just that it's generating things off the screen, basically. And that's, again, the thing that I said we should address if we want to still be able to view it. If we don't care about viewing it, if we want to turn off the map debugger thing, we're actually fine. Oh no, 103 patterns. Pre-deduplication, there are 10,020 or 1,024. Good number, 1024. 2 to the 6th or 8th or something, I don't even know. No, 2 to the 8th is 256, I'm stupid. I know my binary. I know that 2 to the 16th is 65,536. It's just when you're seeing numbers show up, you think different things sometimes. Yeah, I think that'd be 2 to the 10th, right? Because 2 to the 8th is 256, and you double that to 512, then you double that to 1024. I don't know the numbers in between as well. They're still waiting on this, and it's going to take a little while. It didn't fail though. It actually generated something first try. Begin new game. And we have no stairs because this algorithm is broken right now. Oof. Big oof. Also, begin new game. That button's broken, and it's been broken for a very long time, and I called it out a long time ago. I fixed it once, and then the functionality was broken again as we went through more of the tutorial. Alright, I don't care enough to explore it right now. Let's keep going. Voila, you're roaming a huge map. A definite downside of a huge map and rolling a largely open area is that sometimes it can be really difficult to survive. So we're going to revisit draw map for progressive map rendering. If you keep the huge map open, open main.rs and set const show map to false. Oh, wait, I see. Go to main, set that to false, to true. Congrats, you just crashed the game. That's because we never adjusted the draw map function that we're using to verify map creation to handle maps of any size other than the original. Oops, this does bring up a problem. On an ASCII terminal, we can't simply render the whole map and scale it down to fit, so we'll settle for rendering a portion of the map. This is not true. It doesn't crash the game in my case. It just renders a part of it, kind of like they're saying, but we'll see what it does. We'll see what their solution is. Render debug map, camera RS. By the way, Tusk, that was like the only kind of competitive multiplayer I used to like, what you're talking about. But we can talk about that later. I don't want to get too off track of what we're doing here. I want to focus on this. Like, I want to say I see what you're saying, but it's also like way off topic. But I don't want to just ignore it either. Okay, we've done this a few times. I don't know why we're doing this again, because we have a function that should already do the first part here. Oh, no, I think... we'll see. So we get the player position. X cares and Y cares for the terminal size. Center X and center Y. That's like all the same as what we did before. I'm not sure why we're rewriting it here. That's fine, I'll go with it. Actually, the one thing that might be a little different is the player position. Because we don't have a player position, so we're just making a new point in the middle of the map. That's all we're doing. That's the only thing that's different. This is like the same stuff. So much reusable stuff here. That's the dot. I don't know how to draw that, so we'll copy it. Alrighty, there we go. Yeah, we could enumerate that actually. That's interesting. We'll leave it as a loop counter right now because we're running late, but I guess I never thought if you need a loop counter, you can still enumerate something like this. Interesting. So you would turn the range into a tuple like that. Not a tuple, but you'd wrap it. You do enumerate. Yeah, that would also work. That's actually a lot nicer. We'll worry about that another time. I'm going to spend some time trying to clean up a few things between streams. What I might do is actually take a fresh copy of the entire repo and then make slight modifications here and there. Just to get in parity with it again. Actually, this is a good time to do it. Yeah, we'll talk about it in a few minutes because we're wrapping up. That's going to be the plan, and we'll see if I can get wave function collapse into a better state. Because I don't know if I made some errors at this point or what. I get the algorithm, but there was a lot of typing and maybe I made a mistake. It's going to be hard to track down, so we'll figure it out. There's the code, basically what we wrote earlier. It says it's a lot like our regular map drawing, but we lock the camera to the middle of the map and don't render entities. Yeah, that's the only differences. In main.rs, replace the call to draw map. So right here, with a really beefy thing. So it's going to be if self.mapgen index less than self.mapgen history.len. Self.mapgen history. There we go. And we can't find render debug. Oh, render debug map, not that. And self.mapgen index. I wrote it in a weird way. I did self.mapgen index when I needed to do mapgen history first, and then I kind of worked it. All right, now we can go into map and remove some stuff. Draw map. What am I looking at? Hang on. Stop that. Okay, that's just draw map. Kill it. Wall glyph and is revealed. There. And we'll set the map size back to something reasonable, 8050. So we'll go into main. Let mute builder. And we're done. In this chapter, we made it possible to have any size of map you'd like. We've reverted it to a normal size at the end, but we'll find this feature very useful in the future. We can scale maps up or down, and the system won't mind at all. So let's take a look at it. Let me click back into Visual Studio and let's run our code just to get a quick view of it. And there we go. That was very quick. We have a nice little map to run around. We got a nice camera system to use as well. I think we should be putting borders around the map. I would prefer that unless we're going to do like Caves of Cud and have this opening at the bottom lead to another map or something. That would be valid. But until we do something like that, I feel like it's a little hard to know when you're at the edge of the map. It's a little bit almost unintuitive. So if we can get to the edge, I don't know if... Yeah, if we get to the edge here, it just kind of keeps going. And we can kind of tell that we're at the edge because right here we could see this line running up. Like, we kind of know that. But down in the corner, it's not as intuitive. And if we were in a large enough open area, it might be really difficult to know that you're at the edge. And I just can't move right anymore. You know, if I go to the corner here, I can't move down anymore or right. But I am wasting turns doing it. Alrighty. So there we go. Nice improvements. I'm really happy with it overall. I was unhappy with some of the issues we ran into with wave function collapse. That's why I'm going to bother with that a little bit. But I have an idea. So let's go back to the browser because we're done with maybe all the map stuff. Let's look at the conclusion. And it's very short, yes. So it's literally just, and that wraps up section 3, map building. We've covered a lot of ground in this section, learning many techniques for map building. I hope it has inspired you to search for your own interesting combinations and make fun games. Procedurally generating maps is a huge part of making a roguelike, hence it being such a large part of this tutorial. Section 4 will cover actually making a game. Cool. So, now this is why I said I have an idea. And a minute ago I talked about just re-cloning, and like, I think I already have the whole repo cloned. So just picking up this, like right here where we've left off, and starting fresh from it. That way, any changes, now I know I did a lot of things my own way. Instead of those, some of those if-lets, I did let else, things like that. We'll lose a lot of that. I'm not going to go through the entire thing and retype a bunch of very minor things like that, as long as the code still works, right? But if there were any very slight typos that I had that allowed the game to still work, but, you know, maybe not as originally intended, then that's going to be helpful. There are still a few bugs in the game, though, that I'm surprised have lived this long, that are not my fault, even. One of them was the begin new game. Begin new game only works at the start when it's already generated a map, or when you die, and then it completely refreshes everything. If you quit... like if you basically like quit out and save or whatever, go back to the title screen and then hit begin new game, it actually puts you back into your existing game rather than loading, which is kind of odd. So that's a pretty big bug. And I feel like there are some issues with wave function collapse. I'd like to see how that plays out when I get the fresh copy of everything. So that's going to be my first step. I'm going to pull in a fresh copy of everything just after stream here, and then I'll take a look at anything that I may or may not want to change. I'll mess with it a little bit. I don't know how much I'll do. The good news is my next coding stream is Monday, the whatever the next day is. What is it? The 16th of January. And we get that day off of work. So I will be starting an earlier stream on Monday for the next coding stream. It'll be about 10 o'clock my time, 10 a.m. So nice and early. It'll be a chance where if these sections want to run a bit longer, I'm a little more open to that. I'm a little less concerned about, you know, having to go to bed and everything, right? So I think we're good there. We've got the wrap up. Let's take a sneak peek at next time on making a game. So far we've made a skeletal game. We've shown how to make a minimalistic roguelike. We've added some essential genre features to the game, making it more fun to play. We've built lots of maps, a very important part of making fun roguelikes. Now we're going to start a series of articles that actually makes a cohesive game from our framework. It won't be huge, and it's unlikely to challenge for best roguelike ever status, but it will explore the trials and tribulations that go with turning a tech demo into a cohesive game. And there's something here called the Berlin interpretation, something I've heard about before of what a roguelike is. So we'll talk about that. Low value targets and everything. These are basically a lot of the essential ideas of what it is to be a roguelike. And kind of the more you tick off, the more roguelike you are. You don't have to necessarily do all of them, but high value targets are like, these are things that are super important to roguelikes generally. Permadeath, random maps, turn-based, non-modal, what is grid-based, non-modal. We'll probably break this one by having systems that take you out of the regular all-on-one-screen play system. Sure. Complexity, we'll strive for complexity, but try to keep the game playable without being a master's thesis topic, right? Resource management, we've already got some of that with the hunger clock and consumable items, but we'll definitely want to retain this as a defining trait. Hack and slash, exploration and discovery. Yeah, so those are high value targets. Lower value targets are monsters being similar to players, which I like. That to me is very important in a game where monsters are no different than players. In other words, they have all the same systems. They behave consistently. I like that. Single player character. We're unlikely to introduce groups in this section, but we might introduce friendly NPCs. Tactical challenge, ASCII display, dungeons, numbers. This one's a little more controversial. Not everyone wants to see a giant wall of math every time they punch a goblin. We'll try for some balance. So there are plenty of numbers, mostly visible, but they aren't essential to playing the game. All right. So that's just general things that are important or important-ish to being a roguelike. So, I mean, we just kind of skimmed this. We're going to reread this on Monday. I want to take a look at like what we're probably going to be doing Monday because I'm excited. It's different. So we're going to do, and this is something I'm doing, a design document. If you plan to finish a game, it's important to set out your objectives ahead of time. Traditionally, this has taken the form of a design document, master document outlining the game, and smaller sections detailing what you want to accomplish. This is something I am writing myself for my own game because I have so many ideas and I'm putting them all down in documents and basically trying to figure out what I want to really focus on and everything for my own game. Yes, Tusk, Monday, the next coding stream. Rusty Roguelike is a 2D traditional roguelike that attempts to capture the essentials. So this is our design document preview. So we'll kind of read this and work with it. And then what we'll really start focusing on. So there's going to be a lot of reading early on Monday. And then raw files is going to be the real work here. Raw files with data-driven design. So we could see here using JSON, and instead of building out all of our like spawning code and stuff, instead of building out like the spawning code and stuff as hard-coded Rust, we're going to be removing the code, which is actually good and desirable, and we're going to be building up like JSON here. So then our code will read in this JSON and actually just generate things on the fly. So then that's really good for modding and stuff. It makes the game really flexible, where you could go into a file, edit it, and your game is going to be able to read in that file change without having to recompile the entire game. So it's really good for modding, where it allows players to add new things on their own if they want. So it's really cool stuff. So we're going to get into a lot of kind of refactoring, but it is going to be new behavior as well. So I'm really excited about that for sure. And it says down here, yeah, it's going to give us the ability to easily change the items, mobs, and props that adorn our levels. And then we're going to actually adjust. We're going to actually like add more spawning stuff as well, I think. some sanity checks. And, you know, even if we find duplicates, that's cool. Like, we're keeping track to make sure we don't duplicate things, like all kinds of good stuff. And tomorrow is, I mean, for me, it's Thursday, but when I go live at 17, it is around midnight for you. So yeah, I guess Friday for you. But for me, it's Dwarf Thursday, Dwarf Fortress Thursday tomorrow. All right, so that's enough of me rambling on, looking ahead at what we're going to be dealing with. So we'll start here on Monday. Again, early stream Monday, because I will be off of work. So I'll get to start at about 10 o'clock my time, like I do on my early streams on Saturday and Sunday. So it's going to be one of those. So that is it. A big long session today, but we got done with all the map stuff. Again, I'm going to take a fresh copy of the repo as we left off at the end of the map generation and all that, because we're going into a new section now. So it'll be good to make sure nothing got accidentally kind of modified or something in a way that affects the game. So yeah, that's that. Yeah, I don't think I have much else to say there. So thank you to anyone who showed up today, whether you are lurking or chatting. I really appreciate it. If you are new here, if you're watching this right now and you're new and you like coding, you like roguelikes and all that, you definitely want to hit that follow button, because I do these every Monday and Wednesday. If you also want to see gameplay, if you're interested in some of the games that I'm playing right now, those include Dwarf Fortress, Caves of Cud. I'm doing the entire Metal Gear Solid series. We're still on Metal Gear Solid, but we will probably be wrapping that up on Saturday and then moving on to Metal Gear Solid 2 on Sunday. I also play Genshin Impact every Sunday night, once a week, that is. So those are all the things I'm currently playing, but I do play lots of different types of games. So if you're interested in any of that, hit that follow button, come hang out. It's a good time. You can also go over to YouTube if you want to catch any of my previous streams, because these streams go up on YouTube 2 weeks after they're live here on Twitch. Or if you are actually watching this in the future on YouTube, congrats on being in the future. While you're over there, I'd like if you would do the usual YouTube stuff, like, subscribe, notification bell, leave a comment. I do read and respond to my comments. I really appreciate them. So all that's good stuff. Lastly, Twitch notifications. I've had complaints in the past from a few people. It's never been an issue for me personally, but a few people have complained that Twitch notifications are really delayed, like an hour or more from when I go live. If you really want to know when I go live, you can follow me on Twitter, where I do tweet when I go live. Did I tweet today? I hate when I say that, and then I'm like, did I do it today? Because it was part of my rhythm for a long time. And now that I talk about it, I feel like I forget it more often than ever before. I'm checking now. No, it's there. Good. It's there. Wait a minute. It's not there. No. You know what's the worst part about it? I actually wrote the tweet and it didn't submit. I'm going to do something to make it better today. I'm going to do something after stream as well to make it better. So that won't happen. I feel bad when I say that and then it's like, oops, I forgot to do it. All right. So enough of that though. I'm getting sidetracked, but you can follow me there. I usually tweet when I go live, and I don't tweet much else than that. So turn the notifications on. You can see when I go live if you don't trust Twitch. That's about it though. We'll pick up again here next time, again, Monday, 10 a.m. Central Texas time. Well, I think Texas has 2 time zones, but you know what I mean. The main Texas time zone. And yeah, that's going to be it. So until next time. Oh yeah, from the follow earlier. Love it. Love it. Until next time, have a good day. Have a good night. Whatever it is, wherever you're at. Take it easy.